So we've got 2 days of labs. Like I said, Friday during tutorial, I'm going to do a review on working with the gas laws and any other questions that you guys have for the test. Make sure that you've sort of gone through the pre-test before you come if you want to do that with me, so that we can sort of talk about ones that you're questioning and things that you have problems with. I am here before and after school. Please use that time to come get help. Please use tutorials to come get help. If you don't understand something that I'm going through, please ask questions. You got to treat it like it's college, like you're paying for the class. Okay? So if you go to college and you let a professor bully you through or keep going when you don't understand something, you're actually paying for nothing. Does that make sense? So that you guys are paying for the class, you're not paying a lot, but in college you will be. So you want to get everything out of it you can. So if you don't understand something, make me stop. Say, Mrs. Howell, whoa, I don't get this. Let's go back over it. Okay? We are going to do 2 labs, endo and exothermic curve with heat curves today. So you'll be printing 3 graphs today. Next time we won't be doing any graphs. It'll just be a specific heat lab. It's rather quick. And then you'll have time to get whatever else you need done next time also. And if you follow my instructions for this first lab, it should go fairly fast also. Okay? All right, so test is open today and it goes to the 24th. So if you have questions that you need something before you go in and take that test and you don't quite understand how to do it, please come and ask me. Remember that most of the gas laws are going to be in the form of a story problem. Pull the numbers out. Always make sure temperature is in Kelvin when you're working with the gas laws. When you're working with what we're working now, it needs to stay in Celsius. So when you're working with a heat curve or reading off the phase diagrams, they'll be in Celsius. Okay? All right, so let's talk about what you're going to do today. So there are 4 parts, Part A, Part B, Part C, and Part D. We've already done Part B. We did that as a separate lab, the heat diffusion of ice. So you don't need to do that again. You can look back in your lab notebook, get the information you need from it, and just put it into your lab. Okay? Part A, I want you to do as a group of 4. So we're going to break up into groups of 4. So here's your 4, here's your 4, here's your 4, even though there's 3, and there's your 4, and there's your 4. And then the back, I'm going to split you here and here. So you each have 4, okay? So these 2 will go together and these 2 will go together. So everybody has a group of 4 they're working with. If it were me, I would want to work across the lab table from that 4. Does that make sense? So 2 on one side, 2 on the other. So first up, what you're going to do is you're going to get a beaker. You're going to put a magnetic stirring rod down at the bottom. You're going to put it on a stirring hot plate. It has 2 knobs. And then you're going to put an amount of ice in there. Okay? And you're going to put your temperature probe in. So you're going to need to have probably 2 calculators, okay, for one group and 1 calculator for the other group, because every time you do a graph, it needs to be on a separate calculator. Unless you stop and you know how to rename your lists, then you can use the same calculator. But if you don't, it goes over list 1 and list 2. Okay, and I'm not going to take the time right now to show you how to rename lists. But if you know how to do that, you can use the same calculator, just rename your lists before you start a new trial. Okay? So what you're going to do is you're going to get this is linked to an easy link, which is linked to your calculator. Okay, you want to have this temperature as close to 0 as possible to start with. Okay, there is one mistake. So as you're looking at Part A and you get to set up on Part C, or 3, on 3A, it says go to mode. It won't be mode, it will be setup. They changed that. So you'll push the hotkey at the bottom of the screen right here that says setup. And once you go to setup, then you'll set up a time graph. Okay? And you'll use the numbers that are in there for the time graph. And then you'll just say go. You'll start this to stir. This, because this is all ice in here, it won't stir to start with. It will just sort of jiggle. It's okay. You're going to turn this on as hot as it will go. Okay? And you're watching it. Please watch my wires that they don't touch this hot plate, because wires and hot plates don't go well together. Okay? And you'll see some of the hot plates have rubber on them, and that's bad. Okay? So just let it go. So at this point, you can leave this one just to go. As the water starts melting, come back and adjust this. Take it down and then take it back up to about a 6 is where you want the stirring to be. Okay? And if it starts to jiggle when it's liquid and it doesn't stir, take it all the way down and bring it up slow again and it will stir. Okay? But you want the stirring to keep going. At this point, this is where you're going to split and do two things separate. Okay? On part C, I believe, it says you are working with baking soda and acetic acid. That's baking soda and vinegar, guys. Not a big deal. Okay, so you're going to use a styrofoam cup. You're going to have it in a beaker so it doesn't tip over. You're going to have a temperature probe that you're going to use a stirring rod connected to EasyLink, connected to your calculator. And you're going to go and do the setup about the same. So look at C really quickly. Does it say how much baking soda I need to add? How much? How much BS do I need? 10 grams. 10 grams? Okay, 10.0 grams. So there are little weigh cups there, and you're going to put baking soda in there. Okay? We all know the reaction with baking soda and vinegar. What is it? It's going to foam like a volcano. Don't dump it all in at once. Sort of sprinkle it in for a little bit so you can keep it contained in the cup. Okay, so what you're going to do is you're going to get your initial temperature, and then you're going to start each of these times. When you go, make sure you press start. That was a big thing kids forgot last period. And if you don't start it, you're not going to get data. Okay, so make sure you press start. So you're going to go through this one. And you're going to add this slowly. Not real slowly, but keep it contained in the cup. Okay, you don't want it flying out. So one of you groups is going to do that one. The other group is going to, and this is vinegar in here. Okay, vinegar's already in here. On the other one, D, you have a magnesium strip that I will give you. And you're also going to set up like this with the temperature probe, with a calculator. And you're going to put in here hydrochloric acid. Okay? You're going to do start on both of these. Let it sit for a minute before you add anything because you want an initial temperature. You want a straight line for a little bit. Okay, one of them is going to be endothermic and one's going to be exothermic. Okay, if it's exothermic, what is happening to my temperature? It'll increase because the reaction is heating the liquid. Okay, or it will feel hot. If it's endothermic, then it will become colder as far as the temperature goes because the reaction is taking in heat, okay, from the water or whatever's there. Okay, so what we're going to do here is you're going to put the magnesium ribbon in, and you're going to, on both of these, make sure you're stirring. Okay? They should just take a few minutes. You're not going to go the full 25 minutes that this one's going to need. So this one takes 25 minutes. So this is the one you want to make sure you get going really fast and get it working, and then you can go to the other two. Does that make sense? Okay? Once you're cleaned up. So these two right here, there might be some little issue with the procedure. They don't need ice. They don't need a hot plate. The only one that needs a hot plate is A. Does that make sense? Okay, once you're cleaned up with this, you're going to rinse everything out, put it nice and neat right where you had it in your lab area. Come get a stamp from me, and then come in here and work on the computers getting 3 graphs. Okay, you're going to make enough for 4 graphs for each thing that you do. Does that make sense? And then you're going to share the graphs, and then you're going to individually figure out what those graphs mean. Okay, we need to make sure we have a title. We need to make sure as we get our data, list 1 and list 2 is what we want to pull over. We want to make sure we can see what the number is. Because it will be from side to side, it'll be one you can't see unless you take where that little box is and pull it so you can see the number. So make sure, whoa, you can see the number. Okay? You want to graph it. You want to make sure it graphs. You want to make sure you're changing these to time and to temperature. Okay? And that will change it on the graph. okay? And then you'll want to make sure before you print it that you have the highest temperature or the beginning temperature and either the lowest or the highest if it's the exo or endo, okay? Questions? Yes? You're using 3 calculators for each group of 4. Okay, does that make sense? Okay, and I've got calculators back there. I've got extra batteries if the batteries are low. Any other questions? Goggles are mandatory. Aprons are your choice. The only thing that's a little bit iffy is the hydrochloric acid. Okay? All right, so work in your group. If there's 3 people, then I would suggest each one of you take one of them. Does that make sense? All right, go. Should have lots of time. It's back on the back table. Uh-huh.